refresh our memory, the pattern that we developed when we built our cubes last class, okay? So we built a cube that was a 2 by 2 by 2 cube, if you remember our original figure, and these were the perimeter of the base, the surface area, and the volume of that cube. And then I asked you to double it, which has a scale factor of 2. Remind me what the new figures were. What was the new perimeter? Okay, and what was the new surface area? And then it was good. And so what I think we talked about, or at least I'm hoping that we said, is that what's the relationship here? So if 8 times what is 16, okay, and then 24 times what is 96, and then 8 times what is 64, okay, and then I said, well, wait a minute, these are all numbers that are powers of 2, and it's not a coincidence that they are powers of 2, because the scale factor was 2, and if I look at the powers, doesn't that make sense? Don't we square areas? Don't we cube volumes? So that makes sense that that's what you did to get your answer. And then over here, I think we created a new column for tripling, didn't we? Okay, let's just see if we remember how we did it. When we triple something, my scale factor is 3. And we take our original figure and we multiply it times powers of 3. So in other words, this is going to be 8 times 3 to the first, which is 24, right? What would the surface area of a tripled cube be? 24 times 3 squared. Very good. And what'd you get there? I think it's 216, right? And then down here, we're going to take our original volume, and when I triple it, I'm going to multiply it by 3 cubed. And you should also get 216. We did this last time, right? We talked about the pattern and how we can use our scale factors and whether we're using surface area or volume to find new things. So go ahead and open up your packet, and you should see this chart. And we're going to kind of work together on the next couple of pages. The very back page to this, it says homework. Well, it's really classwork. That's where you get your hole punch on your passport, okay? So we're going to do some problems together, kind of like our notes, so to speak, but I've already less for you to write down because they're really all word problems, right? And then the homework problems you'll do, once I've graded them, I'll give you a hole punch and I'll take it back. Do you see how it says O, similar solids, at the top of the page? That means it's letter O on your hole punch. That's why I know it's letter O. Okay? Don't worry about why, just it is. Okay. So, in this chart, well, I should say, we're going to make a chart with all of our similar solids. Before we jump into our chart, can you talk to me about some solids that we already know that have to be similar? Let's pick a solid. Let's pick the cubes, since that's what we started making last class. We built cubes, right? Are all cubes similar? Yes, they are. What does similar mean again? If I take this one shape and I multiply it by a scale factor, it just gets bigger. Same shape, different size. Would you agree? Same shape, different size. All cubes are similar. Give me another 3D shape that's always similar. Spheres. Very good. Spheres are always similar. You can have like a ping pong size ball, multiply it times the scale factor, you can get a basketball. But they're similar. Would you agree? All spheres are similar. Those are really the only two. Why are cylinders not always similar? I can have a tall, skinny cylinder. I can have a short, fat cylinder. Do you agree? So they're not the same shape necessarily. So we have to be careful. But spheres and cubes, always. Otherwise, we have to be told that they're similar. Okay, so knowing that, let's say that we're talking only about solids that are similar. Okay? We can create this chart that relates the area, the volume, and then we have this guy. It could say area, it could say volume. They're going to go in the second and third row of our chart. The top row can really be anything with a linear measurement. It can be height, length, perimeter, diameter, radius. It can be any just measurement. Or it can be area and volume go in a different row. Fair enough? So let's just say hypothetically that I have some kind of ratio. I'm going to use just random letters, and so I want you to be filling in the chart as we go here. And I say that my ratio is simply just A to B. Okay. So when we're going in our chart, we call this up the ladder, down the slide. When I'm starting with the ratio and I'm going down the slide, what do you think we're going to do with the numbers to get to the area? What did we do in the cube when we built it? What did we do with those numbers? We squared it. So we're going to say it's A squared to B squared. Okay. What did we do when we went from our original cube to when we tripled it? Or to the volume, I should say, the volume. We cubed it, right? We cubed it. We cubed that ratio. Very good. So when we start with the regular ratio, and by the way, you always want to get back to that original ratio. But when we start there and we simply go down the slide, we can either just square it or cube it. The problem becomes we're not always starting there. What if we're given a ratio of areas? How would we go backwards to get our ratio? Well, square root. Does that make sense? If we're going forward down the slide, we're going to square it. If we're going backwards from the area, we're going to square root. Notice it says square root or cube root on the left there. That's by design. What if we were given the volume and we wanted to work backwards to the ratio? That's a cube root, okay? And I'll show you today what that is on the calculator. The key is that you always need to work back to the top. So if I was given the volume and I wanted to find the area, I would have to go back to the top and then go down. So we go up the ladder, down the slide, okay? So let's try that. Let's look at this chart that you have. Let's start with the middle column, okay? So looking at your chart in the middle column, just the middle column for now, what are we given? The original ratio, the top. That's good news. Because we know how to go down the slide, right? We know how to fill in the rest of our chart. What would the ratio of those areas be? What would I do with the 5 and the 9? Square it. So wouldn't it be 25 to, beautiful. I agree. And then how would I find the ratio of the volumes? Now what am I cubing? I'm cubing the original one. Okay? So I'm cubing, again, the 5 and the 9. So 5 cubed is? Okay. And then 9 cubed is? Okay. Any questions about that? This is always going to be our first, I shouldn't say always, but 99% of the time, this is going to be our first step, is to create a chart that relates the area, that relates the ratios, the area ratios, and the ratio volumes. All right, so if we have the ratio at the top, we can simply go down and fill out the rest. That's pretty straightforward. Let's go back to the first column now. This time I'm given the middle one, which is the areas. What did I say we always had to work back to first? Devin, put your phone away. I need to go back to the top, right? Always. So I need you to put it away, actually. Devin, thank you. So I need to do what with that 121 and the 144? Square root. Any questions about why I'm square rooting? From area back to the top. I'm going up the ladder. So when I square root 121, you can do it on the calculator. Right. Square root is here. Square root, 121. and you get 11. And when I square root, oops, there we go, square root 144, I get 12. So we should get 11 to 12. Always want to work back up to that original ratio first. Now we're going to go and fill out, we still need to fill out the rest of my chart. So I need to go to my volumes now. How do I get the volume ratio? What am I cubing? The 11 and the 12. Good. So what is 11 to the third power? 1,331. And then what is 12 to the third power?
4,028.
Thank you. I don't have that memorized. Thank you. Good job. Any questions so far? Up the ladder, down the slide. Okay? So let's try the last column. This time I'm given my volumes. Again, the first, oh, by the way, these are decimals, so I want to change this. Is that okay? Because I changed this problem. Yeah, you're going to get decimals. I changed it. So let's change it real quick so it works out just nice for us today to 1,000 to 216. Okay, so make that change, please. Not that decimals, there's anything wrong with decimals. I just think the first time we try it, I want the numbers to be pretty, that's all. Okay? So we have the ratio of the volumes is that. What did I say we always had to work back to first? The first one, right? Which is the ratio of the sides or the lengths or the heights or the radii or the perimeters. Anything but area and volume. So how do I do that? Cube root. I'm going up the ladder, which means I'm going backwards, which means I'm either going to square root or cube root. Since it's volumes, I'm cube rooting. Where is the cube root key on the calculator? Under math. Very good. So when you hit math and you look at option 4 is the cube root. Okay? And I'm going to plug in 1,000. And you should get 10. I'm also going to cube root 216. Again, math. Option 4, 216. And you should get 6. So the ratio here is 10 to 6. Any questions about how I got that? All right, so we went backwards up that ladder to get our original ratio. Now I'm going to go down the slide. So how do I get the areas? Square which ones? The 10 and the 6. Awesome. So when I square 10, I should get great. And when I square 6, I should get awesome. How do we feel about that? The chart's not bad, right? So what I'd like us to think about is when we do these next few problems, I want us to do the chart first. I want us to fill the chart in with whatever ratio we're given, then do the rest of the problem. Sometimes the problems are 2 steps. What's your first step? Fill the chart out. Then we'll go to the second step, okay? So let's go ahead and look at the next page. We're going to do 2 at a time together. And some of them, it depends on the question that's being asked, but they really always start with the table, the chart, okay? So notice it's talking about 2 cubes. Aren't cubes always similar? So I know I can do my chart. So we're going to do our chart. You're looking to see if I'm talking about similar solids. If cubes are similar, I can do this. So I want you to create like 3 rows. The first row is just the regular ratio. The second row is the area ratio. And the final row is the volume ratio. We're going to start this way every time. When I read the first sentence, what ratio am I given? The 27 to 125. And what is it a ratio of? Volumes. So what row do I put that in? The last one. Very good. So I know I'm going to put that down here. Any questions about why it went there? Volumes, right? I'm not even going to read any more of my problem. I'm going to fill out the rest of my chart. If I continue to read, I have more numbers. I'm not ready for more numbers yet. I need to fill out my chart. So I'm going to pause the recording for a minute. I want you guys to think about how I go up that ladder, down the slide, to fill out the rest of my chart. So doing a quick check, it looks to me like most of us got we had to work back to the top, just the regular ratio, and that's a cube root. And so when I cube root these two things, you should get 3 to 5. Okay? Now I'm going to go down the slide. So I'm going to go to get my areas. And to get my areas, I'm going to square these numbers, right? So it should be 9 to 25. Okay? So you want to complete your chart before you continue reading, because I think if you do all at one time, it can be a little much. This is a two-step process. So that first sentence alone allowed us to create this. Do you agree? The first sentence alone. Now let's keep reading. What is the ratio of their surface areas? Well, it's 9 to 25. Do you agree with that? That first question we've answered. Let's keep reading. Find the surface area of, I'm going to stop right there. Find the surface area. That means I'm going to use my surface area ratio to write a proportion. This is like step 2 of the problem. I'm going to find a new area. So I'm going to use the ratio of their areas. It says I want to find the ratio. row? Is it the first, second, or third row? First, very good. I'm at the top of my slide already. I don't have to climb a ladder. Straight down. So I'm good to just square and cube them, right? Go back to your original one, right? So the ratio of the surface areas, what do you think? 1 to? Good. Ratio of the volumes. Yeah, that really was not anything other than just filling out your chart. Okay? Let's try number 5. I'm back to cubes. I know cubes are similar, so I want to make a chart. This one, the ratio looks weird. Do you have a ratio? You can have numbers that you can make a ratio. Let's make a ratio of small to big. You have a small box and a larger box. What numbers do I have? I have 5 and 9. What are those numbers in terms of the box? Their size. So what row is that? The first row, top row, the size. So I'm going to make my ratio 5 to 9 because they're both sides of cubes. I'm not going to read anymore. I'm just going to keep going. I'm going to fill out the rest of my chart. Again, I'm at the top, so I can just slide on down. I don't have to climb any ladders. I'm good. So let's answer the question now that my chart's complete. The question says, what's the ratio of the surface areas? Right? It's just 25 to 81. Things you have to say because I'm through. All right, let's go. Oh, yeah. Huh? Oh, yeah, let's do it. Is it your birthday? Yeah. Is it your birthday tonight? Yeah. Oh, well, happy birthday. We'll sing it. Okay. We won't record it on the video. All right. All right. Go ahead and read the next two. The next two, I don't see the word similar anywhere, but what kind of shapes am I talking about? Spheres and cubes again. So I know they're already similar, so I don't have to worry about that. So again, we're going to make our chart. The ratio can be written differently every time. Sometimes it's written as a ratio with a colon in there. Sometimes it's written as a fraction. Sometimes it's written as a decimal. That's okay. How is this one written? Well, you're just given the two numbers. You're given two diameters. What row in my chart do diameters go in? The top row. Very good. So this is going to be 3 to 8. I'm at the top of my slide. Don't have to climb any ladders. Go ahead and slide on down. Yeah? Check the numbers. Is that what you guys got? Can you fill out your chart? Okay. So now we're looking at the question, and it says, what's the ratio of their volumes? Yeah. Again, it says, what's the ratio? That means I don't have to do any more work. The answer's in front of me. Okay? The first two problems, there were 2 steps, weren't there? So you have different kind of problems. All right. I want you to read the last one. going to do together. And I'm curious to see how you build your charts. So I'm going to walk around. And 5 or 6 of you were able to start your chart correctly. So let's see where we're going to start. If I read the first sentence, it says I have a side length of 5. So where does that go? Top. So it's 5 to something. The only other thing I'm told is that I've doubled the cube. So my new side would be 10. So the side ratios is just 5 to 10. The word double told me what I had to do. Okay? It's kind of like what we built, isn't it? We built this, in a way. Last class. So I'm at the top of my ladder again, I just go straight down. When I fill out my entire chart, I'm here. Do you agree? So what's the answer? Come on, guys, let's think about this. And you're going to work on the problems on your own. When I think about this problem, it says find the volume of the second cube. Volume, what row am I looking at? Last row, so this is my volume row. And I want the volume of the second cube. So which number represents the second one? So the answer is 1,000. 1,000 inches cubed. And that's it. Very short and sweet, wasn't it? All right. So when you look at the back, you are in fact going to have 5 problems. Okay? I will tell you that the last 2, problems 4 and 5, are just like the first 2 problems. They're 2-step problems. You want to look back at what we did, okay? Problem number 2, I want you to attempt, but we are going to talk about that together because that's kind of a different type of problem altogether, okay? So we'll come back to that one. But try all the rest of them on your own. And I'm going to combine, I'm going to hole punch your letter O on your passport when these are all complete and correct.